Hi, this video shows the results of my class project in OpenCV for Faces, taught by Dr. Satya Mallick in the spring of 2018. This class covers much more than just face identification. My project objective is to identify a handful of US coins on a table and display the total amount of currency. This video progresses in 3 segments covering non-touching, touching, and overlapped coins. You will see me move the coins manually as the algorithm runs on each frame in real time. Each frame identifies the valid coins with green around the boundary. The center of the coin is labeled with the diameter in millimeters in red and the cent value in blue. A disqualified object is circled in red. The total number of coins and the total currency is displayed in the lower left corner. The setup uses a standard 480 by 640 webcam mounted on a tripod. The code is implemented in Python and OpenCV on Windows. Identifying coins by their diameter is challenging because the diameters of dimes and pennies differ by only 1.14 millimeters. Also, the color range varies from shiny bright dimes to oxidized copper pennies. Selecting a black matte background was very important in having a background color that was far from the coin color space in HSV. The background material was chosen to maximize the Euclidean distance from the coin color space to the background. The black matte worked much better than a white background. A reference for coin size is a security badge, which is a standard ISO ID1 size of 85.6 by 53.9 millimeters. This is used to calculate the millimeters per pixel in each frame. A complication of the small dimensions and low webcam resolution is the camera distortion creates a measurement error depending on where the coin is in the field of view. To improve this measurement accuracy, the camera field of view was calibrated using a black and white checkerboard pattern that was measured at several different locations, then used to calculate a camera calibration matrix that is stored in a calibration.yaml file. The coin image is measured real time and stored camera calibration matrix is applied to each frame prior to processing. Initial processing is blurring, grayscale, and canny edge detection. The first step after image processing is to detect the ID card and measure the width in pixels. This step is done using affine contours and then using the minimum area rectangle in the largest contour that was found. Fine contour is not used for coin object detection because the algorithm fails for touching and occluded coins. After detecting the ID card and calculating the scale factor, we use the hue transform and specifically the hue circles to detect circles. The transform is applied to the grayscale image after blurring. Once a list of circles is found, the diameter of each object is compared in a lookup table to determine if the object qualifies as a coin type. From this list of possibilities, we examine the color and look to see if the object is a bogus coin, such as a washer. The HSV color of the background is sampled and compared to the center region of the object, and also compared to the color of a penny versus a dime. This combination of features allows us to identify a valid coin type versus a bogus coin. The algorithm is not as robust as I would like. The limitations are discerning small spatial dimensions with camera distortion and a low resolution webcam. Future work would be to adapt this to an Android phone with a higher resolution and use still shots. With higher resolution, we might also be able to identify features embossed on the coins to discern real versus bogus coins. Finally, my warmest thanks to Dr. Satya Mallick and his team for introducing me to computer vision in OpenCV at learnopencv.com.